Like this kind of Bluetooth module everyone must be familiar. Then please pay attention to this snaking track on the Bluetooth module. Yeah, it's the snake again. Last time we talked about the serpentine route, it looked like this. Today's serpentine lines serve as antennas here. There's nothing life-threatening. This issue is safe to eat. Originally, the antenna lines on the PCB were not curved serpentine. It's an inverted F shape like this, known as the inverted F antenna IFA. It's very obvious, but it's more like F. An inverted F antenna is an antenna used for wireless communication. It consists of a unipolar antenna, parallel to the ground one and grounded. The antenna is fed from an intermediate point away from the ground terminal. This design has two advantages over simple monopoles. The antenna is short and compact, and the impedance matching can be controlled by the designer. No additional matching components are required and save money. It's just a little bit of a brain drain. Then, with the miniaturization of market demand, this gives rise to the serpentine inverted F antenna MIFA and the three-dimensional inverted F antenna PIFA. The serpentine to F antenna is due to its small size. It also has no cost and is widely used in various human-machine interface devices. The trace is usually placed on the top layer of the PCB, and the antenna length needs to be adjusted according to the different signals of the PCB to match the impedance and frequency. Cutting the antenna will increase its frequency. Therefore, it is recommended to draw longer lines when the design is uncertain. After all, cutting is much easier than lengthening. The efficiency and performance of these F-type antennas are relatively low and easy to be interfered with by the motherboard. Except for these F-shaped antennas, PCB antennas also have log periodic antennas, Yogi antenna, wheel antenna, Mic antenna, and Petri antenna, etc. It may seem a little crazy, but it is valid and reasonable. Like this log periodic antenna Elder, which looks like a princess iron fan. It is a wideband multi-directional antenna, which is often used for point-to-point communication, can receive and send medium and short broadcast signals. Not only can it be used as a cable TV antenna, but also can receive radio signals. It can also be used to send technical signals of digital base stations. It is an omnidirectional antenna. Mainly, it's waterproof, but it's really not appropriate to take it out. There's also this 2.4 GHz Yogi antenna. The advantages are high gain and good direction. Yogi is a directional antenna. Because they focus all the inputs in one direction, they, therefore, have a higher gain than log periodic antennas, suitable for receiving low-strength signals. Although the bandwidth or frequency range is somewhat limited, of course, no matter what kind of PCB wiring it occupies an area. One type of onboard antenna is very small, ceramic antenna, also known as a chip antenna, due to the high dielectric constant of ceramics, so it takes up less space. It even looks a bit like a capacitor. Ceramic antennas can be adjusted by capacitors and inductors. Therefore, it is especially suitable for use in miniaturized antennas, such as Bluetooth devices and GPS positioning devices. But small ceramic patches cost more, and usually has a particularly narrow bandwidth, and the chip-top ceramic antenna replacement is very convenient. No need to redesign the PCB board. Greater versatility of adjustment. There are also external antennas that can be easily replaced. For example, stick antennas like those used on Wi-Fi routers or IPEX interface antennas. The external antenna has good signal directivity, high efficiency, and strong anti-interference ability, away from interference on the motherboard, and without too much debugging and matching. But the cost is high, occupies a large volume.